Press record. Okay, so yeah, I know you just had a hand in, and I know you're having another hand in, which sucks. But yeah, I guess just come tomorrow during workshop and ask as many questions as humanly possible. Hopefully Sondra will be there as well, so we're gonna be more people to answer questions. Regarding the grading, I think fortunately for you, unfortunately for me, I'm the one gonna still be grading, and I'm gonna have to grade both of them. So that's 170 multiplied by 2, that's 300 and something papers, so bear with me, okay? Yeah, I'm excited, as you can tell. So if you, for some reason, I don't know, need to know whether you passed or not, and urgently, just send me an email, okay? Please don't abuse this and this and that now. Oh, I want to know exactly, everyone wants to know as fast as possible what they got. If you actually need to know, or you're considering you're doing poorly or whatever, and you want me to see if you passed, etc., just send me an email, okay? Or we can just talk about it. I think, again, I said it in the seminar, I'm going to say it one more time again. I think homeworks are more of a kind of a test for you guys to know how you're doing or where you need to work on. But again, let's be honest, you guys work in pairs. We don't know, we don't actually care. We actually encourage you to work as a teams, etc. Or I think we do, etc. So the actual test in this course is going to be the exam. And that's why making mistakes in the homework is not the end of the world. Okay, so don't panic. Because I think I've gotten some emails from people that thought they were failing and they just missed 2 problems out of everything, or etc. So, okay, just focus, and you're not doing bad. Okay, I actually think you're not doing that bad, especially not at homework. Okay, anything else you guys would want to ask me regarding, let's say, arrangements or something like that? I don't know, notes, anything? Okay. Then we're going to go to teaching, and I didn't fall behind schedule. This is the schedule I'm supposed to follow. I have to teach you tomorrow what you need to solve the thing for Monday. So, yeah. So listen up and let's do it. We're going to start differential equations today. Okay, what are differential equations? Well, if I told you we have an equation, look, just a quadratic equation, like ax squared plus bx. I'll just put it further. Bx plus c is equal to 0, right? This is a normal quadratic equation. You've seen it. We know the formula, etc., etc. Well, now in differential equations, instead of having a variable x, you're gonna have, raising that x to the power to the square or whatever, you're gonna have a derivative of it, okay? So you might have something of the type ax derivative plus bx plus c, okay? This is a differential equation. And I'll give you the formal definition in 1 second. But are you ever gonna use the actual formal definition of what is a differential equation? No, it's better just to recognize what is, and that is an equation where you have derivatives of the variable you're trying to find out, okay? So let's just do, like, the definition is an equation for an unknown function, and I'm going to clarify this in a second. And that, I guess, let's make it English. That involves some derivative of that function. Okay, so this is the definition of what a differential equation is, or whatever, what is it? And I said this is a differential equation. Well, why is this a differential equation? Obviously, if I said x prime, I can't take a derivative of 2, right? I need to take a derivative of something. So that x is actually going to be a function of something. And I'm gonna show you examples, so don't worry. But it's basically, if I told you that, I don't know, let's just have an example of let's actually I'll stick to the notations here. Let's just say we have a function x that depends on t, okay? And this is the notation you're going to use throughout this course, okay? X of t is the function you're always going to try to find out. You want to find this function, and you know it's something like x prime t plus bxt plus a constant is equal to 0. And we're gonna learn how to solve this equation. Okay, this type of equations and another one. But this is what a differential equation formally would look like. Okay, it's important again to recognize it, and then we're gonna go from there. Why can't I just zoom out? This is absolutely stupid. Okay. Now, differential equations are really broad. So in this course, we're only gonna focus on, let's just do math, this course. You're only gonna focus on first order ordinary differential equations. Okay, what does this mean? First order means highest order of derivative, highest order of the derivative. Okay, I know this is formal, but what it actually means is that you're never going to have an equation you're going to have where you're going to find x double dot. Okay, you're just going to have x first derivative. That's all you're going to see in your equations. You're not going to see x double derivative. Okay, so that's what this means. And then ordinary, it means that your functions only depend on one variable. Okay, so as I said, x of t, you're not going to have x of tz or whatever. Cool. Okay, now before I think we move on, I think it's important to actually look a little bit on the notation. I'm going to show you exactly what you're using in this course rather than I guess general, because I guess once you understand, it doesn't matter. So as I said, we're going to use x of t as the course, and x is going to be your unknown, which you would want to find out, unknown function. And this is the variable, okay? In your interpretation, this is like the time. So basically, how does x depend on time, okay? So you can take this as how does x depend on t, which is, I don't know, some textbooks, I think even yours says this is like time or something. Okay. Cool. Now, another notation which you will find is x dot. Okay. X dot is nothing else than the derivative of x with respect to t, or x prime of t. All these notations are exactly the same. Okay. I don't know if you're. It depends. I think in most of the problems on Canvas, you're going to have the x prime. On the exam, you might have x dot. Don't panic. They mean exactly the same thing. Okay. Cool. Now, again, some fancy. I know I haven't taught you exactly how to solve them, but bear with me. We're getting there. I'm just giving you all the boring terminology in the start and how to more or less recognize them. Whenever you hear ODEs, okay, this is how nerds talk, and we mean ordinary differential. Yeah, that's what we mean. Differential equation. Okay. Cool. Now, the general form of your function is going to be something like a f of t, x, and x dot is 0. Okay, just like my example. This is the absolute general form, just like my example where I had, remember on the previous page, I had something like x prime of t plus bxt plus a constant is equal to 0. Okay, this is an example of an ordinary differential equation. Eventually, I have some examples you might be able to write. I don't know, x dot of t is equal to some f that depends on t and x. Okay, I think this is even enough for math 2. Niels didn't specify, but I think it should be enough. Okay, basically you're given the derivative as a function of t and x. Okay, and you're asked to find this derivative. That is all that you need to find out. Now, there are two types of solutions to this derivatives. First of all, particular solutions. Okay, and then we have general solutions. The particular solutions are some functions x of t that just fit for all t. Okay, fit for all t. Now the general solutions are not some functions, but the set of all functions. Okay. And I know all this terminology is boring or whatever, but it's really important because sometimes in some problems you're going to be asked for the particular solution, and sometimes you're going to be asked for the general solutions. Again, we're going to do examples and you're going to find out what I mean by this. Okay. Let's just give an example. Again, a general solution. Let's just say, and again, a particular solution might look like 24 multiplied by e to, I don't know, let's say RT, okay? Okay, e to the t, just skip the r for now, okay? This might be a particular solution, and the general solution would just be the constant multiplied by e to the power of t. Okay, so just so you guys understand what the difference between the two is. Okay. Again, tricks for particular solution if you're asked to verify. And now we're just going to go through, I guess, everything that the professor might ask you to do in derivation in this. So the first thing he might ask you to do is verify that a particular solution works. Okay. In order to verify that a particular solution works, remember, if I told you x of t is equal to, what was my example? 24 e to the t. Okay. How do I verify this solution in my differential equation? Well, I just compute x dot or x prime of t or dx dt at t, however you want to call it, I don't care, which in my case is just going to be 24 e to the t, okay? Because take a derivative, nothing happens. And then what I'm going to do is I'm just going to plug in my equation. My equation was, what was it? X, let's just use the notation. X dot plus b x of t plus constant is equal to 0, okay? To 0, okay? And at this point, I'm just going to plug in and see if it works, okay? Disclaimer, it doesn't work. It doesn't work in this case, but I'm going to give you a lot of examples where it works, okay? So in order to verify that a particular solution works, you just have to compute x dot and replace x and x dot. Again, x dot is derivative in your differential equation. Okay. If somebody asks you to verify a solution, all that you do is you just compute the derivative and replace in your whatever thing. Now, he might ask you, but I'm not going to cover this. But I'm just going to put it, since I found it somewhere deep in his notes. So I'm going to put it here. I don't remember necessarily seeing this on any exam, but I'm just writing it here because I have to. It's sketch the directional diagram of your x dot, which is like fx of t. Again, I just mentioned it here. I don't think you should panic about it. I just wrote it, so I have to. Now, in this class, you're going to solve two types of OD, okay? So the last thing they can ask, the professor can ask you to do about OD is solve an actual OD, okay? An actual OD, okay? And there are two types of OD. These are the two general types, the linear case, okay? And the linear case just looks something like x dot plus x multiplied by at is equal to b of t, okay? It looks familiar to what I showed you up top, but I didn't want to include everything all of a sudden. But this is the absolute general case of a linear ODE, okay? And now the other one is the, what's it called? Separable ODE, okay? And it looks like x dot is equal to f of x f of t, I think as a notation, f of t multiplied by g of x, okay? So as you could tell, these two are like, these two ODs are different types, and I'm going to show you how to solve each of them. Today we're only going to do linear and a lot of example, since I think I destroyed your minds for like half an hour with all this theory and names and notation. So let's just see them in application, and then tomorrow I'm going to show you how to solve an OD. Okay, I'm going to show you how to solve separable. Now, what does it mean to solve an actual OD? Okay, what does it mean to solve? Careful. What solving an OD means: finding the general solution. Okay. Okay. This is unsurprising. Finding the general solution. I know, but usually, finding a general solution, that's like the basic. Sometimes he's going to ask you to find a particular solution. And usually the second one is easiest because you can just like steal the answer without actually solving it. And I'll show you how. And lastly, he might just tell you what is the constant if xt0 is equal to x0, okay? And again, don't worry, I'll show you everything. These are like the initial things that they're gonna tell you, but don't worry about any of those. I think it's gonna make a lot more sense once we actually see some examples, okay? Now, I'm done with the theory, promise no more theory up to tomorrow. Let's just go to linear and basically apply everything that we have. So linear differential equations. Okay, I lied. I have to show you how to solve them first. Linear differential equations. Linear differential equations are the form that we just talked about, x dot plus x dot, which again, I'll keep writing it. I know some of you get bored, but it's just the derivative of x with respect to t, okay? I know I'll keep writing it just because, yeah. Okay, now, in this case, for linear differential equations, you can either remember how it's done, or you can remember the formula. However you do it, nobody actually cares. Just get it right, okay? By the way, A and T are given. Like, you know what those functions are. The only thing that you do not know in this case is x, okay? You know it depends on T, but you don't know how it looks like. So you want to find out x. So the method that people use for this is just compute AT as being antiderivative of AT, okay? And multiply everything and multiply both the equations with that stuff. So I'll just multiply E, 8 to the power of t, x dot plus AT x is equal to E, 8 to the power of t, B of t. Okay, I just multiply everything with this thing, okay? Nothing special. Again, if you're unfascinated by this, just wait a little bit. And I'll write you the formula, and you can just remember this deeply, and it's gonna be fine. Okay, now you just observe that this, or if you don't observe, I'll just tell you that this is the derivative with respect to t of EAT x. Okay, and this is just equal to the same thing, right? If I take a derivative of this thing, I'm going to get what's up top. That's the only observation that I can tell you right now. Anyway, if you integrate this, integrate both the equations, EAT x dt is equal to integral of EAT B of t dt, okay? And now it's the integral of a derivative, so it's automatically what's outside. So you just get EAT x plus a constant is equal to this integral. Okay, and now the formula finally arrives. X is just equal to constant, doesn't matter if it's positive or negative, so it's constant multiplied by E A of t plus E, this is minus because I multiply with a minus A of t integral A of t. Okay, and this is the formula that you guys need to remember, unless you want to remember the computation. This is the formula you remember, and it's not as bad as you think. You just literally plug it in. You just plug it in. Once you see a differential equation, you plug it in and you see what you get. Okay. Now, the C thing is a constant. Okay, and that's what I said. You sometimes might need to find the constant, but we'll see exactly how to look at this. Now, I think it's really necessary to take an example. So let's just take an example. I'll keep the formula. I'll just keep my paper here, so I'll keep showing it to you. But let's just take one simple example. Let's have, and I won't do the general case. I'll just do x dot is equal to, that's okay. Okay, let's just put 2x minus 1. Okay. Again, I'm in his notes. He has R and K, which are constants. Doesn't really matter. I think it's perfectly fine. Okay. Now, the first step when you're solving differential equations for the first time is to write it in the way that you learned how to write it, which is this thing. Okay. So I'm just gonna write it exactly as this. Okay. So I have x dot minus 2x plus 1 is equal to 0. Oh, scratch that. Yeah, well, it's not that form. scratch that. So it's x dot minus 2x is equal to minus 1. Okay, remember the formula, the general formula was x dot plus a t x is equal to b of t. Okay, this was your general formula. And the first step is always to write it to this point. Okay, so now what can I say? I can say a of t is equal to minus 2, b of t is equal to minus 1. Everyone follow me? Follow me on what I'm doing right here. Okay, now remember, my first step was compute the antiderivative of a of t. So compute the antiderivative of a of t. So compute the antiderivative of minus 2. What is the antiderivative of minus 2? What if I take a derivative of gives me minus 2? Well, a of t is just minus 2t. Okay, if I take a derivative of that, I'm going to get minus 2. So a prime of t is going to give me a of t. Okay, cool. Well, now I can literally and exactly just plug in the formula, and I'm going to get my answer. Okay, so what do we have here? The formula was, and I'll write it again here so you guys can follow easier. xt was c multiplied by e to the minus at plus e to the minus at integral e at b of t dt. Okay, this was your initial formula. So everything that I'm going to do right now is I'm just going to replace. xt is just going to be the constant, stays there, it's a constant, multiplied by e, my minus, what is my a of t? It's minus 2t, so minus 2t plus e minus, again, minus 2t here, integral of e to, that's a 2a there, right? Yeah. Yeah, so this is a minus 2t. B of t, what is b of t? It's just minus 1 dt. Everyone understood? Made sense what I'm following? So again, when I'm trying to solve a differential, linear differential equations, all I'm doing is I'm putting it in the form that I know how to solve, which is this one over here. Then I'm identifying my at and my b of t, computing the antiderivative of a of t, and then plugging in and replacing in the formula. Okay. And I'm kind of done. All I need to do is just make it look, let's say, somewhat nicer. What does nicer mean? Well, I have a constant multiplied by e to the 2t plus e to the minus plus 2t here, multiplied by minus e to the minus 2t d of t, which, what does this give me? This gives me xt is equal to constant e to t plus e to the power of t. What is the antiderivative of this? I'm pretty sure it's, what is it? I think it's, yeah, it's e to the minus 2t over 2, okay? Plus a constant. I was, in differential equations, really be careful with constants, okay? Really be careful with constants because they can somewhat matter, okay? And you can even put like a constant 1, constant 2. So xt is just equal to constant 1 multiplied by e to t plus e to t multiplied by e minus 2t over 2 goes away, plus constant 2 multiplied by e to t. Okay, and eventually now my answer is x to the power xt is equal to c1 plus c2 e to t plus a half. Okay, can you now question, can you replace c1 plus c2 with just a constant c? Yes, doesn't matter, that's fine. Okay, any questions of how I got this? Okay, any questions of how I got this? Yeah.
So A and B are just constants that we.
In my case, they were just constants. We're gonna do as we go an example where a of t is actually a function of t. But in my case, yes, they were just constants. Yes. In my case, after writing it in the form, I identified that both a and t and b of t were just constants. Okay. And yes, we're gonna do examples where it's not gonna be a constant. Okay. But for now, let's stick to the constant side. Okay, so any questions of how I solved it? I basically just identified a t b t, computed antiderivative of at, which is big A of t, and then replaced in my formula. And I'm done with this differential equation. Now, how do you know that this differential equation is good? Well, we just plug it in, okay? How to check? Plug it in, okay? Plug it in. What do I mean by that? Well, so I know that my x of t is equal to a constant e to t plus a half. Okay. So what is my x dot equal to? Or my x prime, or whatever you want to call it. This is just equal to a constant multiplied by the derivative of 2t plus 0, since this is going to be 0. This is a constant. So x dot is just constant multiplied by 2 multiplied by e to t. Everyone on with this? Cool. Now, I just plug it in my equation. Remember, my equation was x dot minus 2x is equal to minus 1. So let's just plug in. I'm going to have a constant multiplied by 2 multiplied by e to t minus 2 multiplied by x, which is, this is my x. So it's just the constant e to t plus a half. Okay, and I have to get minus 1. Okay, now I don't know, just open the parentheses and it's there, right? It's 2c e to t minus, open the parentheses, 2c e to t minus 2 multiplied by a half is equal to minus 1. This goes away, and this is true. Okay. And I checked that the solution I got works for this. Any questions on this? Okay, now, I told you that sometimes they might ask you, they might tell you something like, find, I don't know, he might say, find the particular solution of x such that I don't know, x of 1 is equal to 20, 21. Okay. At this point, how do you do this? Okay. Well, remember, our solution depends on the C. This C can be anything. We have found the solution, the family of all possible solutions, okay? So how do we find the particular solution such that x of 1 is equal to 2021? Well, we just replace. So my x of t was constant multiplied by e to t plus a half. Okay, so what do I do now? I just compute x1, which is equal to a constant multiplied by e2 multiplied by 1 plus a half. Okay, and I have to make this equal to 2021. So I just get that c multiplied by e to the power of 2 has to be equal to 2020 plus a half, 2021 minus a half, let's say, minus a half, okay? So at this point, I have found that the constant I'm looking for is just 2021 minus a half over e squared. And I am done, okay? And now, if you want to phrase the answer nicely, you can just say, hey, the general solution x of t is, and now you just replace the constant, okay? The particular solution of x, that x of 1 is 2021, whatever, is, and you replace the constant, is 2021 minus a half e squared multiplied by e to t plus a half, okay? And you are done. Okay, any questions on this? Any questions on what I did up to this point? Does everything that all the theory, all the useless theory that I taught you make sense now? Or do you have any other questions on what I said up to this point? Otherwise, we're just gonna take another example and then we're gonna call a break. Now we're gonna take, I guess, a more complex example, since somebody was complaining that the constants. Yes, I'm gonna throw it on you. So let's just say x dot plus 2x is equal to t to the third. Okay. What do I do in this case? First of all, don't panic. Now, write your equation. A of t, x equals b of t. Okay. My suggestion is that until you're like gods with differential equations, always write your functional form the way you learned it, because if you somehow miss a sign by mistake, that will eventually snowball and you're gonna get the wrong constant and then you're gonna get the wrong whatever. So take it slowly. I think you have time. As you can see, differential equations don't really take that long, okay? So now, a of t is equal to 2t, b of t is equal to t to the third. Okay, again, just compared to what was above. Now, the formula, which I never memorized because I can't memorize formulas. I just have to write them down. So okay, your formula was, again, no shame of writing it a million times. Constant multiplied by e to the minus at plus e to the minus at integral eat b of t dt. Okay. What do we notice? We notice that I kind of more or less skipped a step and I don't know what a of t is. Okay. So a of t, anti-derivative of at. Okay. So you can just do integral of at dt is equal to at. Okay. So integral of 2t dt is equal to what? T squared, okay? plus a constant, but you just take no constant. So AT is just equal to T squared. Okay, everyone happy with what I just did? Okay. So now, what am I gonna do now? I am literally just going to, okay, why no constant? Because I'm doing it in A here, okay? And eventually, if you carry that constant in, it's gonna eventually simplify. I don't really wanna show you all the math because it gets complicated besides the point, but just believe me, when you're taking A of t in order to plug in the formula here, do not carry a constant with you, okay? In this case, in linear differential equations, do not carry the constant with you, okay? Yeah. So now A of t is just equal to this. So I just replace xt is equal to constant multiplied by e minus t squared plus e minus t squared integral of e to the t squared multiplied by t to the third dt. Okay, and now everything that's been differential equation related is over. Okay, everything that required you to know differential equations is over in this problem. Okay, now we just got to solve this integral, which has nothing to do with differential equations. I can do it just so we keep the exercise rolling, but I'm gonna take I guess 2 minutes right now and ask if you have any questions on how to solve these linear differential equations. Okay, because that is what I'm teaching right now. This integral, I can just give an example where this integral just vanishes. So, okay. Okay. I guess if there are no questions, I guess I can just do this integral. It's a good example of substitution as well, which I heard it's you might have it in the homework, so I guess it's a good reminder. Anyway, so again, this constant is done. This e2 minus t squared is done. I just need to compute this integral. So let's just see what this integral is. Again, everything that was differential equation related is over here. Okay, this is all differential equations. What I'm solving now is just solving an integral, which has nothing to do with differential equations. How do you solve this? I think you might be able to do by parts, but I think the fastest way is substitution. So I'm just going to say u is equal to t squared. Okay, now du is equal to 2t dt. Okay, and now you know, since we got here, I got some questions regarding do I need to plug in dt here or replace dt in terms of du, or just straightforward replace here with du? And it doesn't really matter. Okay, it doesn't matter. You can do it anytime, any way you want. You're gonna get the same exact answer. Did you have a question? Okay. Cool. So so what do I see? Let's just do it this way. dt is just equal to du over 2t. Let's just do it like this. Okay. So let's just replace in and see what we get. Integral of e. What was t squared? It was u. Okay. Multiplied by what's t to the third? I can just write it as t squared multiplied by t. Okay. So if I write like that, I can just write multiplied by u multiplied by t, because this is, again, this is t squared. So together it's t to the third multiplied by du over 2t. Okay. This goes away. So I just get this to be equal to a half from here, integral of EU multiplied by U du. And now this is, it might look familiar from the homework. It might look familiar for the next homework. This is just a classic by parts application, right? Yeah. Let's just take a 10-minute break right now, and we'll see afterwards if we're doing more examples or you want me to do more like derivative integral computation or more like examples of differential equations. Okay, cool. And just think of any questions regarding differential equations, how we set up the problem, or anything that I might have missed. All right, guys, shall we get back? Okay, so I'm gonna finish this this computation here. Then I'm gonna go again over how to derive the formula in case you actually want to get the formula rather than memorize it. Both ways work again. And then I guess I will just give you another example of this. And I was thinking of giving you like maybe 5-10 minutes to actually see exactly if you could solve it. Again, I'm not gonna grade you, nobody's gonna grade you. It's just you trying to see if you actually understood, and if you got a problem like this, you would solve it. Then I'm gonna solve it here, obviously. And then I guess we can just go to the separable differential equations. I'm gonna present you with a little bit of theory, and we're gonna have all of tomorrow to do all kinds of exercises. Does that sound like a plan? Cool, let's go. So in this case, this is just a by parts application, which is not this lecture. I think I destroyed your brains with that, but let's just do, first part is e to the u. Second part is u. I told you to choose this usually, so integrate this, and you get e to the u. So now you have integral of derivative eu multiplied by u. This is derivative du plus integral of eu u derivative du is equal to eu multiplied by u. Okay, both parts no derivative. Okay, so what do I get here? This is just equal to integral of eu multiplied by u du plus integral of eu du, because u just goes away, is equal to eu multiplied by u. So this is just e of u plus a constant. So I get integral eu multiplied by u du is just equal to e multiplied by u minus eu minus a constant. Okay. This is, again, this integral is just this one. Obviously, didn't change. Okay, cool. Now, what do I have to do? I have to replace this in my formula right here. Okay, remember, this is where I started. This is what I got. So that's what I'm doing. I'm just gonna replace that. So my x of t is equal to constant multiplied by e minus t squared plus e minus t squared multiplied by, remember, I had a half here, which I conveniently never drag after me because I guess I'm lazy, but you should drag it. It's multiplied by a half multiplied by eu u minus e to the u minus a constant. Problems here, again, t and u don't mix, so I just got to replace my u, which was t squared. I get xt is equal to constant e minus t squared multiplied by u et squared multiplied by t minus et this t squared minus a constant, and this is your final equation, and you're done. Okay, you can rearrange, make them nice, look nice, your call. And you should, I guess, technically make them look as nice as you can, since in case you might want to compute the equation, it might come in help. So I'll just do it. Let's just write them as nice as we can. Xt is equal to c e minus t squared plus e minus t squared, and I just distribute this. E t squared minus t squared. I'm just distributing everything that's inside the parentheses, okay? Minus e minus t squared half multiplied by e t squared minus, and I'll just write it here, minus e minus t squared. So copying this again, minus 2 multiplied with what's left, the constant. Okay. Xt is equal to C e minus t squared plus here e minus t squared, et squared goes away, so it's plus 1/2 t squared. Here it goes away again, so it's minus half minus e t squared multiplied by 2 multiplied by a constant. Okay, so I can just factor this in. Again, you can have constant 1, constant 2 if you want, but in this case, it doesn't matter because I'll just get constant 1 plus minus constant 2 over 2 from here, plus 1/2 t squared minus 1 over 2. Okay, again, if you wanted to check that this is the correct answer, please feel free to compute x dot and replace in your equation. And replace in your equation, which was x dot plus 2tx is equal to t to the third. Okay, compute x dot and replace in that thing. Okay, in order to make sure that what you did is correct. If it works, it's correct. Also, again, here I can just write c. Okay, just a constant. I don't need to have c1, c2 in that case. It's just a constant. Okay, cool. Again, cool. Now somebody asked me about how to derive it again, so I'll go over the derivation again. The way you derive the formula. Are there any questions here? What I did outside of the integration computation, which I guess I did a little bit faster because integration isn't really part of this lecture. Okay. But any questions here? Okay. How do you compute the formula? So you start with the general expression, which is this. Then you compute the antiderivative of a of t, no constant. Again, no constant. You're going to carry it for nothing. And then you multiply this step. Multiply equation by e a to the power of t. Okay? That's how you get that equation. And then you observe that this thing is just the derivative of this. Okay? It's just the derivative of that. So you have this being the derivative of that. So you integrate both parts. So from here, integrate it. Okay. After you integrated the thing, you get integration of a derivative. So this thing is just what is inside. Okay. Integration of a derivative, as I said, they cancel out. They're more or less opposites. It's like plus and minus, or division, whatever. Okay, and I get the same thing plus a constant is equal to the same integral. I haven't not touched this integral because I don't know how to solve it. There's no general form to it. And then out of here, I just divide everything by e to the at. Okay, I just divide everything by it, and I get this constant multiplied by e to the minus at, so I divided by it, plus e to the minus at multiplied by the integral. Okay, this is again the derivation if you want to determine it on the spot. If not, memorize the formula. I don't know if you're going to have it on the cheat sheet. Hopefully you will. You can ask the Professor Paul, he knows more about that. But just plug in the formula. Okay, now I'm just going to give you an example. I'm going to give you like a short Roolery computation example, since I believe I'm supposed to teach you how to solve them. And then math-wise, I was told to take that more as given. So let's just take like a small example. Let's just have like 10 minutes and see if you could give me So I give you this differential equation, x dot minus tx is equal to -5. And I want you to find the particular solution for x of 5 is equal to 10. Okay? And remember, in linear differential equations, when I'm asking you to find me the particular solution for this thing, it means I'm asking you to find me the constant. Okay? I'm asking you to find me this constant over here. This is what I'm asking you to find. Okay? To find me this constant such that this equation holds. Okay? And I'm going to give you, I don't know, 5-10 minutes, at least you know if you started on your way, etc. And then I'm going to solve it, obviously. I'll use all the formulas, etc. I don't even mind if you talk to each other. It doesn't matter. All that matters is when you leave this thing, you can solve a linear ODE, okay? Okay, guys, I think it's enough. Also, I think I might have given you something. The integral that cannot be solved is highly possible. I think I forgot it too in my head, but you should at least have gotten on the right way. Okay, so how did you guys do it? Okay, it's I kind of thought of it as you guys were going. I was like, hey, it looks kind of hard. Okay, so the way you do it, right? You just write your function, pretty standard, like this, ATX plus B of t, equals B of t. This is how you start. No. Yes, this is how you start, correct? And now you just notice, hey, my A of t is minus 5, minus t. Sorry about that, was already, okay? And my B of t is minus 5, okay? Now, what do we do? Compute the antiderivative of A of t, antiderivative of A of t. A of t, which is integral, so I just integrate over minus t dt. And what did I get here? I got minus t squared over 2. Okay, that's constant here, but it doesn't matter. Correct? Now I just plug in the formula. Again, writing the formula here. It's xt constant. Yeah, I think I messed up. Minus at. Okay. EAT B of t dt. Okay. So I have here, and what do I do now? I just plug in this, which is my A of t. Okay. That's how I computed it. So I just plug it in. So I get xt is equal to constant multiplied by e to the minus t squared over 2 plus e minus t squared over 2. Yeah, I think I messed up. T minus t squared over 2 multiplied by b of t, which is minus 5 dt. Okay, is this what you guys kind of got? Okay, well, that's good. Now let's just pretend you guys solved it, because this integral is unsolvable. But anyway, joke aside, if you got c of e of t squared over 2 plus e t squared over 2 multiplied by e of minus t squared over 2 multiplied by minus 5 dt, you solve this differential equation correctly, minus you have to solve the integral, which I assume you guys got stuck, because I would get stuck at it as well. If I were to change it, I would just put a t here or something to make it look nice, but I think it's beside the point. After you solve the integral, supposedly you could minus my mistake again. If you are planning on replacing t inside the equation, and making it equal to 10, okay? In order to compute this c, then you're gonna do perfectly the problem, minus my derivation mistake, which again, just leave it at that. I don't want to make it worse than it already is. But yeah, this is the mentality that you have to do, and this is, I think, the hardest you're going to get on linear differential equations. And it's good that you know the method and you're comfortable with it. Again, on the exam, you're not going to get this that which is unsolvable. You're going to get something that is solvable. Probably is going to be somewhat uglier than what we solved up to this point. But even if you just start the process and get to this point, you're still going to get 90% of the score. Okay, and it's in the last 3 to 4 years, there always has been a problem in which they asked you to compute the solution to a linear differential equation. Okay, so if this was your logic and this is what you're planning on doing, then it was correct. Again, for those on Zoom who I muted myself and they missed a bunch, I gave this problem and I said, okay, try to solve it. And the way you solve it is, again, you put your general equation, how it looks like, you make AFT equal to what it is, BFT to what it is, compute the antiderivative of AFT, put capital AFT, and replace in the formula, okay? Dot, dot, dot. The problem with this example is I created the unsolvable integral, which we're not gonna get into that, but if you got to this equation and then we're planning on solving the integral, you did everything that you could do about differential equations correctly, okay? Now, I asked for the particular solution of x of 5 equals 10. So all you had to do is replace t inside the equation and make the equation equal to 10, okay? So if you just computed x of 5, okay, and replaced 5 everywhere, dot, 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 which is like e like 5 squared over 2 plus e 5 squared over 2 multiplied by my integral, which we're not going to debate right now. If this was equal to 10, okay, if you were planning on doing that and then getting the c out of there, then you're doing correctly, okay? And I think up to this point, we can move on to separable differential equations. Again, yeah, this is unsolvable. So I tried giving like a simple example, so you don't need to actually compute the integral, but somehow succeeded because you can compute it, but not in the way I planned to. Okay, so let's see, what can I teach on separable? Okay, separable equations are of the type x dot is equal to f of x multiplied by g of t. Okay, scratch that. He has the other notations. X dot is f, again, doesn't matter, but let's stick to the notations that he has here because might be helpful for notes or problems or whatever. It's basically you write this derivative as a function of t and a function of x, and they're multiplicative. Obviously, the linear differential equations, and I couldn't write, so let's just write separable Odes, okay? Okay, yeah. So obviously, they're completely different than this, okay? You can't write, they're not gonna be the same. So they need to be solved differently. Now, it's important to note that when you write this, and I'm going to write it again just so you see the form, it's important that g of in here, I have no t. Okay, in here, no x's. So examples of this can be like x dot is equal to e to the power of t multiplied by e to the power of x, or x dot is equal to e to the power of t multiplied by x squared minus 1. Okay, these are examples of separable ODEs. Why are they called separable? Well, because that's how we're going to solve them. But really, really important, how to get particular solutions. How to get particular solutions fast. Okay. So you're just trying to make g of x equal to 0. Okay. Particular solution. Let me give you an example. Let's take the example I wrote up top. For how to get particular solutions. If I have x dot is equal to et x squared minus 1. If I take x equal 1, which is x equals 1, okay? If I take x equals 1, constant 1, what's going to happen in this case? Okay? What is the derivative of 1 with respect to t? 0. This is equal to e to the power of t multiplied by 1 squared minus 1. This is going to be 0. So 0 is equal to 0. Correct. So the way in separable equations to find particular solutions really fast is to find constant solutions for g of x. Okay, if you find a solution for g of x, it's always going to be in this form. It's always going to be written something like this, something like this. And if they ask you, hey, find me a particular solution for this separable differential equation, what you need to do is just to find a constant that is a solution for g of x, a constant such that g of x is equal to 0. Okay. I think even in your problem, you kind of have in your homework, kind of have something like this. Okay, like show that it has this particular solution. It basically asks you, and again, no disclaimer given because it's whatever. They're basically asking you, show me that there is a 0 for that g of x. Okay, and that is comment on your homework. Feel free to quote me on that. But this is how you find particular solutions really fast in separable ODEs, and that is look for the zeros in g of x. Okay, find me something, a constant that is 0 here. Okay, cool. And this is really important because you will get problems where you're asked about particular solutions in this thing. Okay. Now, how do you actually solve them when you're not doing this kind of stuff? Well, you just have how to solve them. How I remember it is separable, right? Separable. That is what they're called. So idea, separate everything. Okay, what do I mean by separate everything? Well, I have the general equation. X dot is equal to f of t multiply g of x. Okay, so I'm just going to separate them. I'm going to separate everything that's x on one side, everything that's t on the other side. Make sense? So I'm just going to have x dot over gx is equal to f of t. Again, parentheses here for gx not equal to 0. So not the particular solutions. Okay, makes sense up to this point? This is how you remember this whole thing. Now, what is x dot? X dot is dx, okay? It's dx dt, it's whatever you want to call it. But the idea is you have dx g of x is equal to f of t. So you integrate this. Unfortunately, for separable differential equations, there is no absolute general solution I can give you. And you just got to memorize how to do it. I don't think it's really that hard. So you separate everything and then you just integrate, okay? It's literally that. And then you're gonna get integral of gx dx is equal integral f of t dt.
Does this dx?
dx is gx. Dx, well, dx is dx becomes, well, x dot is kind of a dx, right? Is the derivative of x.
So where's the dt?
Dt goes on the other side. That's why I have dt on the other side. Okay, just again, we can talk it afterwards, but just this is the correct formula. I'm 100% sure. I understand where the question comes from. If you guys want me to ask afterwards, I can go why this is true, but for now, just stick with it, okay? So you integrate this and you get this, and now you just get, what do you get? Let's just say that h prime is 1 over g, h prime of x is 1 over gx, and f prime of x, the primitives basically, right? f of x. Okay, let's put t here to big standard. Okay. So you compute this derivatives. That's the whole idea. You compute these two integrals. You compute these two integrals, and then you're gonna get the solution being h of x is equal to f of t plus a constant. Okay, and this is the best kind of general formula I can give you. Okay. Now, again, let's start again with this. How do you compute them? How to solve them? Because in this case, I can't skip this and tell you, hey, use the formula. You really got to kind of understand why it is. The way I remember how to solve them is separable. Okay, so I separate everything. I put everything with x on one side and everything with t on the other side. Then I integrate both of them, and I get this. Okay. Now, I just compute these integrals, and I get the solution as h of x, which depends on t and c. Okay. On t and a constant. Okay. Now, any questions on this? Again, I think we have time for a couple of examples. Yes. It's the derivative of h. Yeah, it's 1 over g. It's I'll write it again. Derivative h of x is 1 over g of x. It's basically this integral. Okay, I'm just writing it so that it's equal to this integral. And this f prime of t is equal to small f of t. This is it's the same thing, just ugly, nice. Okay, or try to be nice. Okay. Now be careful in separable. Be careful. I mentioned here g of x not equal to 0. Okay. So what does that mean? It means that if I want to find out the general solution or / all the solutions for a separable ODE, I have the formula that we just got there. So we had all the x's that satisfy h of x is equal to f of t plus a constant. Okay, all of that. But now we have any constant solution such that g of x is equal to 0. Does it make sense? Okay. So previously in the linear ODEs, once you had the general thing, the general formula for solving the general formula, you had everything. You were done. Okay. In this case, you have to get the general formula, and you have to get any constant solution such that the g of x is 0. Okay. Because the problem and why you need to do this is because you can only solve the separables for g of x is not 0. Okay. Because I divide here by g of x. I cannot divide by 0. Okay. Okay. Let's see. Let's take an example. Let's just take the simplest again and see how this works. Let's just have x dot is equal to Rx. R is a constant. Let's just take 3x. It doesn't matter what number I put here. Okay. X dot is equal to 3x. Okay. Now, the first step is look at the constant solution. Okay. No, the first step is to write your general form. What is your general form? Your general form is x dot is equal to f of t multiply g of x. Okay. Now, same as before. My f of t is just 3. My g of x is just x. Okay. Now, first step is to look at constant solutions. Okay. So constant solutions, particular solutions, whatever you want to call it. What is the constant solution in this case? How did I define them? I defined them such that g of x is equal to 0. Okay. G of x is equal to 0 implies x is equal to 0. Okay. So this is a constant solution. Constant solution. Now what I can do is I'm just going to apply the method I told you. So I have x dot. Now I just solve it. X dot equals 3x. Now, x is not, in the case that x is not equal to 0, I can just divide by x and I get x dot over x is equal to 3. Or, so you either do this and follow through the computation and then say, hey, we integrate this. Integrate this and you get integral of 1x dx equals integral 3f of t, 3 dt. Okay. Or it's possible. You can remember this formula. If it's good for you, I don't know. Anything that works, I guess. 1 over gx dx is equal to integral f of t dt. This formula you can use. This formula you can just plug in, okay? This formula you can just use. I know it's not really a formula that solves everything, but it's a start. So you can just say, you can just keep this in mind if it works for you and just replace g of x and f of t. So I'll write it here. My f of t was 3 and my g of x was x. So I can just replace them here. And I have 1 over x dx is equal to integral 3 dt. Okay, any questions here? Okay, now what do you guys do? You just compute the integral. What is the integral of x on the left? What is integral of 1 over x? It's just log of absolute value of x is equal to what is the, I'm looking here, by the way. So I said that log of x is the antiderivative of 1 over x. What is the antiderivative of 3 with respect to t? It's just 3t. So this is just 3t plus a constant. Okay, so now x is just equal to e to the 3t multiplied by, okay, plus c, which is just e to the 3t multiplied by ec, e to a constant, which is just e to the 3t multiplied by a constant. Makes it easier, okay? Because constants can be whatever, so we can just write it as it is. Okay. Cool. Any questions what we did now? Okay, now what can we do here? Yes. Why no constant after log of x? Yes, good question. So yeah, I'll answer the both questions. The first question was, why didn't I put a constant in both places? Why didn't I put a constant? Why didn't I put a constant here and here? And when I wrote the equation, I only put a constant here. Okay, and the reason for this is it's absolutely the same thing, since the constants can be whatever. Let me show you. Let me put a constant. Okay, so this is just equal to log of x plus constant 1 is equal to 3t plus constant 2. Okay, and now I just move this constant here, and I just get log of x is equal to 3t plus constant 2 minus constant 1. Okay, these two constants can be whatever. So I just replace this with just a one constant. Does that make sense? Does that answer the questions why I didn't put both of them? Yeah, it just goes away basically. Anyway, yeah, this is it. This is separable. I don't think we have time to go over like another full example. We'll go tomorrow more in examples, I guess a little bit more complicated. And I promise we can try probably the same exact thing where I kind of give you 5 minutes to see how you can solve one of these. Hopefully this time you could actually solve it. That went out pretty bad, but yeah. Hopefully you guys learned something about differential equations, and I'll see you guys tomorrow. Okay.